So section 413 is titled Factoring More Quadratics. So we started factoring yesterday, and today's lesson is only 1 page long. So we're only going to do page 6 today. And we're going to answer the question, how can I factor this? All right, so in just a minute, we're going to break up into our groups of 4. And for each group of 4, we're going to use 2 Chromebooks, okay? One of the Chromebooks you're going to have open to the CPM algebra tiles if you need it. And then one of the Chromebooks should be open to the Desmos scientific calculator. That way, if you need to try some multiplication and some division, it's just right there ready for you to easily go. If you have your own handheld scientific calculator, that works too, okay? But the Desmos is pretty accessible. All right, so for question 24, it says factor each quadratic expression below if possible, and then use a diamond problem and an area model for each, okay? So for A, you're going to draw your diamond problem, and you're going to draw an area model, and then you need to show your factored form, okay? To get the diamond problem, you're going to multiply the x squared times 9. That's where the 9x squared comes from. And then the sum comes from the middle term, this 6x. So you have to figure out what multiplies to get 9x squared, but adds to get 6x. So that would be your 3x and your 3x. Okay, 3x times 3x is 9x squared, and 3x plus 3x is 6x. Okay, so that's how it fits into the diamond problem. The same problem fits slightly differently into your area model. For your area model, you put the x squared here and the 9 there. Then the 3x and the 3x from there can go in this box and this box, and then that will help you factor it to your x plus 3 and your x plus 3. So when you go to write your factored form, you're going to have x plus 3 times the quantity x plus 3. If you also want to use the CPM algebra tiles to help you get that, some students like to see it visually, okay? So for part B, you're going to fill in the top box with 2x squared times 3, which is 6x squared. And then the middle term is 5x, so it goes down below. So in your team, you're going to need to figure out what multiplies to get 6x squared and adds to get 5x. Those 2 terms go here and here. Then you'll fill them in here and here. So you'll be able to factor above and to the side. And then once you factor above and to the side, you can fill in your binomial times your binomial. Okay? Let's do one more setup for you. So for part C, you're going to multiply x squared times negative 7 to fill your negative 7x squared into this box. And then your middle term is 5x, so that goes in the bottom of your diamond. And then in your team, you need to figure out what multiplies to get negative 7x squared, but adds to get 5x. That fills in there and there. And then when you get your terms, you can fill them in there, and then factor and fill in here and here. And then you'll be able to write your binomial times your binomial, okay? For each of these problems, you're going to do a diamond, and you're going to do an area model, and then you're going to write the factors, okay? It does say up here that, notice right here, if possible. That means that at some point, you're probably going to have one that's not factorable. Okay, so you might have one that's not factorable, all right? Question 425 says, you have been working with quadratic expressions written in the form ax squared plus bx plus c, but what if a term is missing? Or what if the terms are in a different order? Consider these questions while you factor the expressions below. Share your ideas with your teammates and be prepared to demonstrate the process for your class. Okay? For part A, notice it has the 9x squared, which is normally the first term, and it has the -4, which is normally the third term. So when you multiply 9x squared times 4, you get -36x squared, and there's no middle term, which makes it 0x. So what's going to multiply to get 9x squared? Sorry, -36x squared. I was looking at the wrong spot. -36x squared, but add to get 0x. That means they're going to have to be opposites of each other, right? Okay. Once you find out what those opposites of each other are, you fill them into your area model, and then you'll be able to factor and write your binomials here. Okay. B is a little shorter problem, and you actually only need your 2 boxes for your area model. It kind of is going to look like part D. Oh, here's my hint. So B is similar to D. On D, you're going to look for the greatest common factor of both 40 and -100. My hint is that it's 20. So you're going to factor out a 20 and write what's left in each of these boxes. Okay? My hint on part C is that you need to change the order, right? It's not exactly in the correct order. So if you change the order, rearrange them to the proper order, then you should be able to do your diamond problem and your area model. And then down for question number 26, just has another one. So draw your diamond, draw your area model, and you're going to do, you're going to write your factor as a binomial times a binomial. On 26, it says, compare your answer with your teammates' answers. Is there more than one possible answer? So when it asks a question like that, sometimes that's indicating that a couple of you might have the same answer as someone on your team, or you might have a different answer as someone on your team, and you both might be correct. There's more than one correct answer for that one. Okay? All right, so go ahead and grab your desk and turn into your group of 4.